preliminary mentioned, if we go all the way around the circle, we're talking about 360 degrees. Now, there's no way to get a protractor out and to say, okay, here is a 360-degree arc. Because think about this, if I make a smaller circle, okay, whatever, let's say this is 90 right here, okay? It's a 90-degree angle at that one, which means this arc from here to here, oh, I missed it, but anyway, is 90 as well, okay? Not to be confused with, look at this 90-degree angle right here and this 90-degree arc. You know, they're really not, well, compare them, they're not the same length. So make sure we're talking about measure here, not length. Because the length is really talking about the size of the circle. Okay, like if you stretch a string into a circle, okay, and you cut off pieces, those are arcs. Okay, measure central angles versus measure of what we called yesterday last class, the intercepting arcs. Okay? Again. All right? So, they are the same. So, instead of versus, let's just put is the same. Okay? It's the only way we can do it unless we have other information. The only way we can find the measure of arcs is to find the measure of the central angles. Okay? So, I divided this up. There used to be something on the smartboard that would do it for me, but I couldn't find it the other day. So let's say I got 90 here, and then I went half again, so that this is 45, and then I went half again, so what's half of 45? Right. So this arc right here, where's my circle, is at 22 and a half. The arc, because the central angle is 22 and a half. Okay, so, heard about that? That wasn't real clear. It wasn't clear at all in 12 too. And you need to know that for a couple of different signs. Okay? So central angle, remember, is the center of the circle vertex where radii sides. All right, so any questions about that? Let's move on to the next page. Okay, inscribed angle. Okay, remember we had an inscribed rectangle the other day in one of our homework problems. We had that in our 12-1 notes, what's inscribed. And remember, an inscribed rectangle was something like this. Or, I guess it doesn't have to be a rectangle, let's just say it's a quadrilateral. This is an inscribed quadrilateral, okay? Where all the sides are, what are they? No. The sides are lengths of the circle. What are they? Chords. There you go, Lindsay. Chords. Okay? So, that's an inscribed quadrilateral from 12.1. We're going to now talk about all those inscribed angles. So, we got 4 of them. Here's one right here. Here's another. Here's another. So, there's 4. And here's the last one. There's 1, 2, 3, 4 inscribed angles. All right. Look at the definition of an inscribed angle. It's an angle whose vertex is on the circle, okay, and chord BC. Look at your vertex right here on the actual circle. Okay? Now, the very important piece of this instruct angle is to find this intercepted arc. The same concept as we had with the central angle. What angle is in between the two rays? That's my intercepted arc for my central angle. And that's my intercepted arc for my inscribed angle. You take the angle and push it together. That would be the arc that we pushed out. Okay, that would be collapsed, whatever you want to call it. Okay? Intercepted arc is huge. We're going to spend a lot of time on that today. Because it connects through numbers. Okay? All right. Do you have any feel for the size of the inscribed angles? Everybody got this page? Okay, I'm going to go back here. And I'm going to get rid of some of these. I lost everything in that. Okay, I'm going to draw myself a inscribed angle. I'm going to use this point. And I'm going to go to the here for one chord, and then I'm going to use the diameter for the other. So I'm going to go there and there. Okay, that's an inscribed angle, right? The yellow one? Okay. All right, so let's say, let's figure out all these chords. This is so messy. It's just going to make you crazy to figure everything out. It's going to make you crazy. I'm going to do it again. All right. Circle. Arc. Okay. That's a 90. Here, I'm trying to figure out arcs. And let's do half again. That looks like half. Would that be close to half? Okay. So what I want to do now is figure out from all the dashed lines and the fact that we got 360 to work with, and the half, so the half, da 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 da. Okay. So I want to figure out all the arcs. So what's this measure of this arc? Assuming this is half. 45. That's 45. That's 45 also. That's 45 also. And you know, that would make that 45 as well, right? From here to here. Because 445 equals what? 180, right. And that's half the circle, so that's what I make it. Okay. So this is 45, 45, 45, 45. All right, now, let's complete, I did my diameter, let's make a different chord, and let's put it right here. Okay? So I'm trying to figure out what this and this angle are. Right? So let's see if I can find a protractor here. Any guesses to what the protractor is going to tell us? Yeah, but it's, sorry, that's a dumb question. It's going to tell us. Yeah, let's see. I was trying to do protractor. In here. Nope. Okay, never mind. All right. If you had to guess what that angle was, what do you think you're guessing at? 45. Would you all say that's a pretty good guess? Okay. So what's the relationship between the yellow angle and that's an excellent guess because that's exactly the right answer, and the intersected arc. The relationship between, there's my intersected arc, my yellow angle is my inscribed angle. What's the relationship? If that is exactly 45, the arc is twice. Okay. The angle is half. Okay. So go back to your notes right here. I don't know. She just was eyeballing it. I'm thinking. Well, I know. We're going to go there. Yeah, we're going to go there. I was just going to say, okay, that's a reasonable guess, and it ends up being exactly right. Okay, I couldn't find my protractor, so let's go here and let's just decide, right, and just real quickly, we're going to categorize, classify central angle or inscribed, okay? Because the measures of them are totally different, you gotta know the difference, okay? DGB, DGB, central angle or inscribed? Central. Look at the center, it's G, okay? DGB is the central angle. What about FGE? FGE, central again. We have, the center is G, the radii are the sides. All right, what about HAB? HAB, inscribed, all right? A is the vertex, it's sitting on the circle, okay? What about EGD? Excuse me. Oh, EGD, EGD, central again, okay? EG and GD are radii, G is the center, the central angle, okay? ABE, AB, all the way to E. Inscribed. A, B, E, B is my vertex. That's inscribed. B is sitting on the circle. All right, G, D, C. G, D, C. I'm going to erase this. Okay, I'm tricking you on EG, GDC. You think it's inscribed. Wait, I got 3 here and a 3 here. Look at GDC. Would you call that an inscribed angle? I wouldn't call it central angle either. What's the vertex of GDC? D. D is the vertex. And the vertex is on the circle. Right there. Okay? But now look at one of the sides. GD. And DC. This is a chord. What's that? Okay. So technically, it would be neither. Okay? Technically. Now, we could do this business, and now we're going to call it inscribed angle, but its endpoint would not be G, it would be up there where it lands. But we wouldn't be able to find the measure of it unless we knew its intersected arc, and it doesn't have an intersected arc unless it intersects the circle. Okay? If you haven't noticed, intercept and intersect kind of sometimes get interchanged. Okay? It's okay to do that, but all right, so here is what Lindsay was asking about. This is what Mary figured out from the one example. The measure of an inscribed angle right here is equal to blank of the measure of its intersected arc. And what did we say it was? 2 half. Okay. The fraction 1/2 of the intersected arc. All right. So if this is X, the intercepted arc, the angle is half of X. All right? Now we are going to go the other direction where, oh wait, this is now X. Oh no, it's all different variable. let's call it y now. So what's the intercepted arc now? To y. So the arc is twice the inscribed angle. Okay, and when I say arc, I assume you know that I'm talking about the intercept, not the arc, not just any old arc. Okay? Alright, so our figure in example 1, it's pretty complex pretty quickly. Alright? So you got some writing at circle O. They're telling us what about O? This is measure of the circle. Okay. AB, the measure of arc, AB is 140. So I'm going to put 140 right there on the arc. Okay. CB is 100. So I'm going to put 100 right there. And we're going to go from point to point. And that's typically what you're going to do, point to point. AD and DC are equal. So I'm going to put tick marks like I would. Now, it's clear that I've drawn very nicely with this. So please note, not drawn to scale, which is not that unusual. I'm trying to give you no clues on the figure. I'm just giving you, don't forget what I told you. Okay? So, doesn't look like BD to me is a diameter. Does it look like it to you? BD. Is O on BD? No. So keep that in mind. Just FYI, BD is not a diameter. Now, again, sometimes they'll tell you that stuff. One time when I get my agenda there. BD is not a diameter. They will tell you that circle O, but then it'll be actually on BD, and then you're like, okay, that's what they're telling me that is a diameter. Sometimes they do a good job of doing that, sometimes they don't. Okay, unmeasured with numbered angles. I've got some different box. So, measure of angle 1, measure of angle 2, measure of angle 3, 4, and 5. Now, what kind of angles are all those? 1, 2, 3, 4, 5. We have a name. What kind of angles are they? No, that's not the name I'm looking for. And you're inscribed angles. Okay. All right. Inscribed. Maybe my shadow's not allowing me to write it. Okay. So they're all inscribed angles. So here's what you need to remember, that they are half of the intercepted arc. All right, so I'm going to actually draw the arc, and I'm going to leave the M out of the measure of the intercepted arc just so you can be clear about what arc you're talking about. Okay, angle 1. What is its intercepted arc? There. AD. Does everybody see that? It's very important for you to see that. Remember, AD, if you look at angle 1, here it is, AD is where it cuts it, the AD is in between. Okay? Alright, what about measure of angle 2? What is its intercepted arc? Alcimatis, number 2, what is its intercepted arc? BC, very good. Alright, what is the arc, intercepted arc for measure of angle, for angle 3, Lindsay? BC. Okay. And what about angle 4, Hannah? AB. And what about angle 5, Annalisa?
Angle 5 is
Intercepted arc is
easy.
you see that? Okay. All right. So, what is the measure of AD? All right. AD has a tick on it, tick mark on it, and so we probably should find that. Any suggestions? We got got 140, we got 100, and then we've got two arcs that would complete the circle. Bridget? 360 minus what's used already was 240, okay, so that's 120, right? Very good. So 60 and 60, okay? A lot of times when I start these problems and they're pretty elaborate, I'll go ahead and get all these order figures, and then I have them, and then I can see what I can do with them. Okay, so AD 60, so half of 60 is 30, all right? What's DC? 60 again, so half of 60 is 30 also. All right, half of BC, 50. Half of AB, and half of BC. We already did that once, right here and here. There's a half of the same arc. We wouldn't have had to do the math again. Remember that, okay? So those are inscribed angles, half of their intercept of the arc. The intercept of the arc is huge to find. Okay. Circle O again. Now this time, this is the diameter. There's a square on. That is a diameter. Okay? That's how we'll be looking at it. See how this was off? That is not a diameter. Okay? So this was a diameter. And I'm supposed to find the measure of angle A. Wow. I need an intercepted arc. Okay, I'm going to put some letters on here just so we can talk. Let's make this point B and this point C. That's the first. There we go. Okay? So I'm looking for angle A, which is really BAC, right? All right, what kind of an angle by name? CAB is angle A. What kind of an angle is it? By name, don't say it to inscribe it in. Okay? So what do we need to find? Intercepted arc. That's right. And what is the intercepted arc? It's where it intersects the circle. All right, here's my A, angle A. Okay, remember if those rays were closed, what arc would collapse? House mass? It could be here and E here. Intercepted arc for CB, and since I put D in there, we'll do CBD, right? Okay, CB are the ends, that's where, and then, okay, now what do you know about CDB? Allison's arc there. What do you know about it? Anything? CDB, the arc. Measure of arc, CDB. You know anything about it? What? No? Okay. What do you know about it, Bridget? Certainly is. It's half circle, right? So, you see it now that you pointed out? Okay. So, we got an angle measure without any angle marks on your arcs. Okay. So, angle A is what to the arc? What's intercepted arc? Half of it. So what's the measure of angle A? 90. Because it's half of 180. So see, you have to really look for that. Because they're like, wait, I must be missing something. Because I'm seeing numbers on there. So look for diameters. Okay? Because those will split the circles. Alright. Number 3, find A, B, C, and D. Okay, I'm looking at A, B, C, and D, and I'm seeing what kind of angles on Lisa. Kind of angles are they? Inscribed angles again. Okay. Inscribed angles, A, B, C, D. We're looking for measures. So angle, so they have an intercepted arc. All right, what's the intercepted arc for angle A, Elena? BC, are you sure about that? Here's A. BCD. And I like how she was specific. She could have said BD because we would have known, but BCD is very clear. It says start B, go through C, and into D. Okay. And what is the measure of BCD while we're here? 190. So half of 190 is 95. Great. Okay. 190. I'm going to go ahead and put 95 in there, even though it's big, but okay. All right. What about B? What's this intercepted arc? Katie. ABC, very good. Again, it doesn't matter if it's probably smaller. The angle B cuts into A and C, and there's D in between, so it's very clear. And what is the measure of angle ABC, Katie? Very good. Okay. And 154, last class we talked about minor and major. That's a minor arc, right? It's okay to name minor arcs with 3 letters. It's just not okay to name major arcs with 2 letters. Okay, so what's half 54? 77. Very good. So B is 77. All right. How about C? What's this intercepted arc, Lindy? BAD. BAD. Very good. BAD. Again, very clear. C cuts. C through circle and end of the A in between. Okay? And what's the measure of BAD, Miss Lindsay? 70. Yep. And so half 170 is 85. Very good. Okay? All right. Get that out of there. Write 85 in here. That was C. And finally we're ready for B. All right. What's the intercepted arc for angle B, Mary? ABC. Very good. And the measure of ABC is what? Mary? 206, and half of that is? Okay. All right. Notice anything about any of those angles? Do you have anything in common? You may not notice. Anybody? See anything? Okay. We'll come back. All right. Remember what a corollary is. Corollary is a direct result of a theorem. This is a direct result of inscribed angles theorem. Okay. We've already done all these examples. Okay. First one says two inscribed angles that intersect on the same arc are congruent. Okay. Let's look at a double page here. See these two I starred? They intersected the same arc, so they're congruent. Okay? Now, that's like the corollary, because yeah, you can get along without it, but it's kind of a nice shortcut. If you see it, wait, that's the same thing. I'm not going to do the math again. Okay, so this is illustrated in example 1. All right? And I'll start that just so you know that's where we illustrate that same arc. Okay, corollary 2 says an angle inscribed in a semicircle is a right angle. That's where you have to see, oh wait, that's a semicircle, so that's going to be automatically a 90-degree angle. That's sample 2. Okay, now here's what I want you to see. It would be very hard to see with those numbers because they're not like nice numbers to add. But check out the opposite angles of a quadrilateral. Okay, the opposite angles are what? B and D? Okay, when you add B and D, what do you get? 77 and 103. What's that? 180. And the same thing's going to happen with the other two. This is example 3. And let me go back to the single page. and be more specific here. In an inscribed quadrilateral, it can't be just like, oh, here's a quadrilateral, okay? It has to be an inscribed quadrilateral. B and D are going to be supplementary. So they're going to add up to 180, and so are what are the two? A and okay. That one's nice, especially when they don't give you all the arc measures. And you can say, well, I don't need that arc measure, I know those are supplementary, so I'm good. Okay? So the corollaries are shortcuts. Remember them, it will be helpful. All right, so let's see if we can use a corollary here on this last problem, example 4. Triangles ABD, okay, and ADE are inscribed in circle F, okay? Now, basically, they told you they're inscribed. If they look inscribed, you can assume they're inscribed. That's not something they're always going to tell you, okay? But it's okay to assume that. All right, with AB, the arc, and this should really be congruent to BD, the arc. So AB, the arc, and BD, the arc. Okay. So from before we get too far into the problem, tell me what you know now. In addition to those arcs are congruent, tell me what other things you know. Hannah? Wait. Okay, the whole A and the whole B, they're supplementary, okay? I'm not going to mark them the same. Okay, and so we need to use like B, A, E, and E, D, E are supplementary. Okay, that's from the corollary above. Okay, I guess that's not even what I was thinking yet. I'm going to get rid of the marks here. Okay, you see, it's called, here's a subtle way they called AD a line, and see the point? So you need to please know that AD is a diameter. Okay? Like I said, sometimes they'll tell you that, sometimes they'll tell you it's subtly, but it's very clear, yeah, that point is on that line or it's not. If it's a little bit shifted, it's not. Okay? All right, so that's a diameter. All right. What do you know? Okay, so those are supplementary. What else do you know from the corollaries on this page?
Those equal angles are 90.
So which angles are 90?
The arc AB and arc AB are 90.
Because
it's like a circle.
okay. Arc AB and arc BD, the measures are both 90. Say it again.
Because they add up to 90, which is 70.
Right. If this is a diameter, this is 180 degrees on this side. If those are equal, they're 90 apiece. Okay, that's good. Okay, I'm not getting what I'm looking for. I'm looking for second corollary. Can you tell me something about the second corollary? Elena. There you go. That's what I was looking for. Angles E and D are 90 degrees. The measures. Get rid of this congruency and put an M instead. Okay, so I'm going to mark this 90, 90, and that way, got that. So we got everything marked except for Hannah's thing. I don't know if that's going to be helpful this time, but certainly something to think about. Okay, so we get rid of my diameter just because I want to focus on the figure. Okay, I'm looking for what? Find the measures of each numbered angle. So I'm looking for 1, 2, 3, 4 measures. Okay. And then they give me some information about measures of 1 and 2. So let me get this stuff out of here a little bit. smaller. This is the stuff I'm including here. Okay, you want to use it. All right. I'm going to start with that upper triangle with 3 and 4. What do we know about 3 and 4? They are. And they're both half of 90, right? So what are they? Okay, so they're half of, I'll just be real clear here. 3 is half of what are? ED, which is 90. 45. Oops, not 40. Okay, very good, Barry. And then, so is 4. 4 is half of 80. Which is 45 as well. Okay, so we got 2 down, 2 to go. All right, 1 and 2 are on that other triangle. I erased my right angle, so I'm going to put that back. Okay, now, don't assume 1 and 2 are equal. Remember what we know about 1 and 2. Are they equal? No. Okay, what do you know about 1 and 2? They're 180? They're 90. Who said that? Elena? How do you know they're 90? Okay, that's what, not even where I was going, where I thought you were going to go. That's good. Because if these are 3, 4, 45, those have to be the same sum in order to make those equal to those. Okay, that's kind of neat. How about we forget about that top triangle ABD and just focus on ADE? Why did you know 1 and 2 are 90? This way. That's right. And you got the 90 and stuff, the other 2 are 90. So regardless of how you get there, 1 and 2 are 90, so the measure of 1 plus the measure of 2 equals 90. So we'll plug in 12x minus 8 and 3x plus 8 equal to 90. Alright? So 15x, the 8's cancel, which is nice, equal 90. What's that? Alright. Now we're ready to plug in for 1. 12 times 6 minus 8. And 3 times 6 plus 8. 18 plus 8 is what? 80. You all catching up? 26. And then 72 minus 8 is 60. Okay. What's the measure of angle 1? 72 minus 8. Yeah, I'm not sure. Okay, so 64 and 26 have to be 90? Yes. Okay, then you got everything. So it's getting, like, really, there's a lot of different ways you can go. So that'll grab some of you nuts, and that'll be fun for some others. Okay, because it's like a puzzle. Well, we do that, but anyway. Okay. It's a theorem, 12. No name. The measure of an angle formed by a tangent. Remember what tangent is again? What is that? Yes. And it touches the circle in one place. So this is my tangent right here. Okay, and it touches the circle right there. That's the point of the tangent. And this is, notice the angle with the chord. Notice where the vertex is, because that's important for you to remember all these down the road. When the point is on its half of the intercepted arc again. Right? The tangents. The angle form a tangent and the chord. The vertex sits. Vertex is on the circle, just like the vertex of an inscribed angle. They are found exactly the same way, half of the intersected arc. So it's nice to remember that connection. Where is the vertex? It's on the circle. You take half of the intersected arc. Okay, because you're going to have lots of them that are in, you already have the central angle, which is different. Now you have an inscribed angle. Now you have a tangent and a chord. Okay, so application here. AJ is tangent. Okay? Now they're going to make a kind of a standard statement at the beginning of your homework problems. They're going to say, if any lines look like they're tangent, they are. It says the same every single time. Okay? So just to know that if it looks like a tangent, it is. All right, tangent to circle O. What do you know about this line right here? Just by according to where the dot is. QL is the diameter. Okay? They're not always going to tell you that, but it is something that they're giving you enough information for you to get that. Okay. So we're looking for X and Y. X is this little corner right here. Let's start there. I'm going to highlight it. It goes like this. Okay? That's X. All right. What is X formed with? Tangents. And what is that other line? JL. Chord. So that is a direct result of this. Okay? So that angle X, I guess I can call it X, is half of the intersected arc. Okay, now, the whole thing about the intersected arc still applies, even though it's on the outside. We took this and squeezed it. And now we're squeezing this together. This is the arc that would be collapsed, right? The intersected arc then is what? What's the name of it? Right here, intersected arc. There we go. So what's the measure of JL? Oh, we don't know that. Okay, so we've got some work to do. We'll hold on to that. And do we know it? Not written there, but hey, what do you think it is? Is it 35? That's right. Did you get it when that happened? I know. All right. Remember, this is an inscribed angle, but you were good to think, oh, wait, we can figure that out quickly. So you were good, just not quite used to. If this is an inscribed angle, let me do green here. If this is an inscribed angle, 35 is half of its intercepted arc, which is also JL. So JL must be 70, because half of 70 is 35. Okay? So that means we can put a 70 in here and yes, 35 correct. Okay? So good for you, Hannah, you started it. All right, now I'm looking for Y. Let's see. I'm about out of color. Let's do purple. Okay. Y is this angle right here. Okay, what kind of an angle is Y? Inscribed angle again. Very good. Notice where the vertex is sitting on the circle. Okay. Y is an inscribed angle should be half of its intersected arc. What's the intersected arc? QJ. Good K. Do we know what that is? Let's see. We know this arc, we already said is 70, right? Okay? Don't forget, we know QL is diameter. So everything on this side is how much? 180. So I got 70 used up, so what's left? 110. Put it right in the arc, and that way you know what it stands for. Okay? It gets kind of convoluted if you're not real organized about where you're putting stuff. All right, so 110 is the QJ. So what's Y? 55. Yes, very good, Mary. That's exactly where I was going. Good job. Okay, so if you got a right triangle right here, yeah, that would have been a lot easier, wouldn't it? We know this is 35. Wait, how do you know that's right? It's the tangent and the rate. Wait, no. No. You don't. It's inscribed in a semicircle. Okay? Inscribed, good job, Annalisa. Inscribed in a semicircle. So it's a right angle. And then that would just be 90 minus 35, which would also give you 55. So you can do it that way too. But really the key to this problem was really to recognize that diameter, wasn't it? Because we would need it here. Oh wow. Or we would need it for that inscribed for the rest of the arc. Okay? So you can see the problems are getting kind of like complex, aren't they? All right, what kind of time? We'll shut this thing off. 47 minutes left.